ఇక్కడ కట్ చేసుకోరా, క్లాస్ అవుతుంది ఇప్పుడు. ఇక్కడ అక్కడెక్కడ క్లాస్ ఉందా? క్లాస్ ఇక్కడ అవుతుంది, క్లాస్ అవుతుంది. ఓకే 1 minute. ఓకే. Yes, good afternoon, students. Exactly at 3 p.m. we are going to start the class. Is my voice is audible? Any one student just unmute yourself or else mute it in the chat. Manusha, voice వినిపిస్తుందా?
వినిపిస్తుంది సార్.
Okay, right. Yes, within 2 minutes we'll start. But before we start, I would like to show you the syllabus once again of power electronics. Let me share the syllabus slide. Right. So power electronics unit 1, we do start, we take the particular topics here. The unit 1 is entirely power semiconductor or power switching devices. So where we first discuss regarding the silicon control rectifier, and then we move to the UJT, uni-junction transistor. Then we concentrate on power MOSFET and different topics. So what exactly the concept of power electronics, all are 2 marks questions we do concentrate today. Right. Now let us go back to the class. Now we do start the class. Right. If you see the syllabus, introduction, first unit is introduction of the different components, and thereon we got the AC to DC converters, choppers, inverters, followed by the converters. We do all the topics. Yes. Right. Good afternoon, everyone. Now, power electronics, immediately, the power electronics is a branch of science which deals with control and conversion of electric power. So immediately, power electronics, what exactly we operate? We do concentrate on control and conversion of electric power at load terminals. So so let me admit the students. For electronics, immediately we have to concentrate on control of the power and conversion of the electric power. So what exactly, one second, is a problem with the animation. One second, I'll sort out this. Right. So power electronics, what exactly the word control stands for? We do control the speed of the motor. In our power electronics subject, we do come across the technical words control and conversion. So what exactly the word control stands for? Control in the sense, controlling the speed of the motor. If you look at the animation, so why we have to control the speed of the motor? So if the speed of the motor is controlled, any object, example lift system or electric train or electric vehicle, movement is also controlled proportional to the speed of the DC motor. So controlling the speed of motor is done and implemented with the help of power electronics concept. Now, how we control? So in order to control the speed of the motor, what are the techniques we use? So we actually depend on controlling the values, controlling in the sense, as per our subject, we control the values of the current, power, as well as the voltage. So current flowing through the load, voltage across the load, and power transfer to the load, all these 3 factors we concentrate using the power electronics subject. So why the control is required? Right? Why the control is required? So in order to control the position of any object, right? Anyone should unmute yourself, all students, unmute yourself, all students. So in order to move any object or else in order to develop any electric train, we require the power electronics concept in that one. So in the power electronics concept, the control means the speed of the motor has to be controlled. If the speed of the motor is controlled, then immediately we can control the position of any object. So how we obtain the speed of the motor to be controlled? So by changing the values of current, voltage and power, current flowing through the load, voltage across the load and power transfer to the load, we can obtain. So how we implement this one? So what are the first applications of power electronics? If you see this particular robot, the head movement is controlled. The head movement. If you see this particular robot, the head movement is controlled by the motors. The head position contains the different servo motors. Even the hand elbow points contains the motors. All these motors are rotating in nature. So this motor speed has to be variable. It should not rotate in at constant speed. In order to obtain different applications, we should make the motor to rotate at different speeds. So power electronics applications involve the industrial machines, robotic system, even in the spacecraft. One second, all students, please mute yourself. Okay. There is disturbance with one student. Right. Please ask all the students to log in at the time. Right. So okay now. So how this robot is taking decisions, it is moving from one place to another place. Entire operation of the robot is controlled by the motor, and motor speed and direction is controlled by the power electronic devices. So what are power electronic devices? So we do come across this silicon control rectifier. Yesterday itself we have mentioned uh, why not germanium control rectifier? Why only silicon control rectifier? Because the answer is germanium reverse saturation current is in the range of milliamperes, whereas the SCR, the reverse saturation current is in the range of microamperes. Reverse saturation current is the current due to minority charge carriers. It increases with temperature. If I am developing germanium control rectifier, as the temperature increases, uh, the heating of the SCR will be initiated. So we go for the silicon based devices everywhere. So now let us see what exactly we have to learn from the SCR. What is the main point with respect to the SCR is SCR controls the speed of the motor by changing the values of current, voltage and power. So we all develop these circuits. The ultimate aim of these circuits is to control the value of current, voltage and power. So let us check the next one. So today we concentrate on working principle of the SCR. That is the topic, today's one. Right. So first, before we take the technical explanation of the SCR, let us have a look at the history of the SCR, silicon controlled rectifier. So where it has developed in the England, AT and BT Bell laboratories. Engineers working at AT and Bell laboratories first initiated. They have just combined the p-type and n-type silicon conductors, semiconductors. You can see on the screen. First, engineers thought, let us check what exactly happens if you are just joining the p-type semiconductor and n-type semiconductor. And this combination leads to a technical word is nothing but diode. Di means two, ode means electrode, a device with two electrodes. But what is the application of this device? So diode is used as a rectifying device, but the complete name is uncontrolled rectifier. Diode can convert bidirectional current to unidirectional, but it cannot control the flow of current flowing through the load. So that's why the complete name is uncontrolled rectifier. We have mentioned on the screen. Now, once again, during the decade 1930s, this diode has been came into the existence. Now, after 1930, the engineers working at Bell Laboratories thought, why not we'll add one more layer to the existing PN type. So to the existing PN layer, engineers added one more layer, which is nothing but P. You can see the second image, P and P. So when these three layers are combined together, the new device name is nothing but transistor. It acts as an amplifier. It will not convert AC to DC. So it acts as an amplifier, which can amplify the weak signal to the strong signal. The strength of weak signal will be increased to the strong signal. So it is used for the amplification process. So during the year 1957, once again, the engineers at AT and Bell Laboratories thought, why not, what happens if we are adding one more layer to the existing PNP? So the newly formed device is PNPN layer, the device. So four different layers with three junctions. If you see the diode, which has got P type and N type, it has only the presence of one junction, whereas the transistor has got the two junctions. So with the addition of extra layer, N layer, the four-layer device has got the three junctions, J1, J2, and J3. And what are the applications of this device in the year 1957? So what engineers have came to know, this device can be used as the controlled rectifier. A control rectifier in the sense we can convert fixed AC current to variable DC current. So when variable DC current is applied to any motor, that motor rotates at different speeds. Not only the control rectifier, it works as the inverter. Inverter in the sense many engineers think it just convert DCs to AC. No, the electrical engineers can develop fixed DC to variable AC current. Then even it can, this particular device can also change the fixed frequency to variable frequency, even the fixed DC voltage to variable DC voltage. So the entire electrical and electronic industry has been revolutionized with the creation of the silicon control rectifier. So if somebody asks you as an engineer, you should start with the existence of the diode. Initially, diode was manufactured. One extra layer is added to the diode. Thereafter, after adding the extra layer to the transistor, we obtain the PN silicon. So now this is the simple basic introduction of the silicon control rectifier. We just go with the explanation now. Right. So now, as I mentioned, SCR, what it can do, we can obtain the control rectifier, which is called as the converter, which convert fixed AC power. Now, this definition is important. Many books also mention the converter or rectifier, which converts fixed AC to variable DC. We should pronounce in the appropriate manner. It converts, the converter converts fixed AC power to variable DC power. We are not just converting the voltage or current, we are converting the entire power and energy. So what is a control rectifier? Another name is converter, which converts fixed AC power to variable DC power. Similarly, inverter, fixed DC power to variable AC power, which can be implemented by the SCR. So cycloconverter converts fixed frequency to variable frequency. You can ask one question, sir, we are getting 50 hertz supply. We are using everywhere. What is the use of converting fixed frequency to variable frequency? Here, fixed frequency in the sense 50 hertz can be reduced to 23 hertz or 16 hertz. What is the advantage? By changing the frequency, also we can control the speed of the induction motor. So in many industries, the induction motor speed is controlled by changing the frequency. How to change the frequency? It is again implemented by power electronics circuit concept. So next one is nothing but AC converter, which convert fixed AC power to variable AC power, which is nothing but the example of the fan, what we use in our regular life. So chopper, fixed DC to variable DC. So these are the applications of the SCR. So as we mentioned, SCR, what we can obtain the SCR in different forms. We can develop the different variety of circuits. These are the circuits and their introduction. Now, explain the working principle of SCR. We are starting the working principle of SCR. SCR, as all people have studied their diploma also, SCR is a four-layered, three-terminal device, a three-junction device, four-layered, three-terminal, three-junction device. Okay, that's okay. But what exactly the new points you are going to gain in this particular class? So SCR contains four layers, PN, PN. You can see on the screen. So why the four layers? If they are using the PN, it is just a diode. It cannot obtain the variable DC. So we can convert only AC to DC. PNP, it is the transistor. PNPN is performing the application of inversion, conversion, and even variable frequency. So this is the device. This is a constructional diagram. SCR is a 3-terminal, 3-junction, 4-layered device, PNPN. Now, if I'm having the SCR, okay, what exactly I can do? If I'm just having the SCR, can I develop any electronic circuit? No. Every electronic device should be biased. You can see the definition here. How to explain in the examination? The entire notes I will be providing, the soft copy, no need to worry. But here through the class, you should gain how we, in short form, how you can go ahead for the explanation. So if you are having an SCR, you cannot convert AC to DC or else DC to AC immediately. You should bias the SCR. What is the biasing? The application of pure DC voltage to an SCR is called biasing. So in order to operate this one, we should apply the proper DC voltage. So biasing is nowhere related to the AC. AC current is bidirectional. We cannot obtain the uniform flow of the electrons. In order to obtain the uniform flow of electrons, we should go for the biasing, which is called as the DC biasing. That is, a pure DC voltage or a battery should be connected to the anode and cathode terminals of the SCR. Now, one more definition is triggering. We come across in the later stage application of any external signal, pulse signal, sinusoidal signal, square wave signal to the SCR is nothing but the triggering. But right now, for our working principle of operation, we develop this circuit based upon the biasing. You can also find the SCR symbol, which contains anode, cathode, and gate. The cathode should be represented by K. It is in the slide. It is represented by C. Right. So, what is the introduction of the SCR? What are the applications of the SCR? So, SCR is a 4-layered, 3-terminal, 3-junction device. That's okay. Now, how we operate the SCR? SCR should be properly biased. So, we just move to the next slide here. Right. Now, so you can have a look at on the screen. Now we are supposed to bias the SCR. That's why the biasing, in the sense, right. Now, how we bias the SCR? SCR has got anode, cathode, and gate terminal. So anode should be connected to the positive terminal, cathode is to be negative. Now, application of pure DC voltage to the SCR is called the biasing. So forward biasing definition, what we have studied, if P type is connected to positive terminal and N type is connected to negative terminal, it is called the forward bias. But what is the next level definition is how we can confirm the SCR is forward biased. So just move to the next one. In order to explain the working principle, so first the SCR PNPN layers are connected to the DC supply. You can have the next slide here, where SCR is practically connected to the DC supply in the forward bias condition, P type to positive terminal, cathode to the negative terminal. So what happens? So many books they have written directly. You can see this particular statement. All textbooks have mentioned when SCR is properly biased. Here the word properly represents the accuracy of the DC voltage, how much you are applying. When SCR is properly biased, junctions J1, J3 are forward biased and junction J2 is reverse biased. Okay, but the question is how the junctions J1 and J3 are forward biased and why only junction J2 is reverse biased is the explanation we have to concentrate. As any student during the explanation, as you have done with the diploma also, you can raise any question. Okay, be free to raise any question, any doubt also. Right. So now you got the SCR. SCR has got anode, cathode, and gate terminal. So first we discuss how to turn on the SCR without using the gate terminal, and thereafter we move to how to use the gate terminal to turn on the SCR. Okay, there are two methods to turn on the SCR. So what is the use of the gate terminal also we discussed. So gate terminal is especially used to turn on the SCR. Gate terminal controls the flow of current from anode to cathode. So if you're having an SCR, first SCR should be properly biased. Okay, this is the biased circuit diagram of the SCR. So first imagine that we are not using the gate terminal. That is, yes, you can have this particular slide. Now here PN layers of SCR are not connected to the gate. Gate terminal is entirely open. We are giving the explanation only with the anode connected to positive terminal and cathode connected to the negative terminal. Now my simple question, if anybody can answer, you can answer. Right. So in every textbook, if you see, when SCR is properly biased, the junctions J1, J3 are forward biased and junctions J2 is reverse biased. So any answer from anyone regarding this one, you can unmute, you can unmute and you can mention why only J1 and J3 are forward biased and why J2 is reverse biased. Yes, I'll give the explanation for that one. Right. If you see, what is the definition of forward bias is important. Okay. So let us see what we have written for the, if the, so forward bias definition, the new definition is if the voltage at P layer, here you can see the PN. If the voltage at P layer is greater than the voltage at N layer, then the diode is said to be forward biased. If the voltage at N layer is greater than the voltage at P layer, then the diode is said to be reverse biased. So SCR is a combination of number of PN, NP and PN junctions, which are nothing but the diodes. So let us go back to this definition. Right. So forward bias definition says that if the voltage at P layer is greater than the voltage at N layer, then the diode is forward biased. So when the voltage at P layer will be greater than the voltage at N layer, only at one condition. If the current enters the P terminal first, then the voltage at P layer is greater than the voltage at N layer. Imagine the current is entering the P layer first, then the voltage at P layer will be greater than the voltage at N layer. If the voltage, you can see the definition of reverse bias. If the voltage at N layer is greater than the voltage at P layer, then the diode is reverse bias. Forward bias, the junction is on. Reverse bias, the junction is off. So now we go with the circuit. This is the circuit. Now, what is the explanation we have to put in the examination for the working principle of SCR? SCR is a 4-layered, 3-terminal, 3-junction device. When SCR is properly biased, the junctions J1, J3 are forward biased and junction J2 is reverse biased. Why the junctions J1 and J3 are forward biased? Here we go with the explanation. Let us take. Now you have a look at this particular diagram. The positive terminal is given to the P type here. So current enters which terminal first? Current always flows from positive terminal to negative terminal. So current enters the P terminal. Okay. Now if the current enters the P terminal, then the voltage at P layer is greater than the voltage at N layer. Therefore, the junction J1 is forward biased. Similarly, what is the next layer current is entering? It is the N layer after P layer. If the voltage at N layer is greater than the voltage at P layer, then the junction is reverse biased. So here we come up with the explanation why the junction J1 is forward biased. Junction J1 is forward biased since voltage at P layer is greater than the voltage at N layer. As the P layer is left to the N type, the junction J1 is forward biased. Similarly, for junction J2, voltage at N layer is coming first here, you can see. Voltage at N layer is greater than the voltage at P layer. Therefore, the junction is reverse biased. Now, anyone can you tell me for the junction J3? Junction J3, we are having the P type is left to the N type. So voltage at P type is greater than the voltage at the N type. Therefore, the junction J3 is forward biased. So we just take this one. Yes, please don't log in late. It will be a disturbance to this slide now. I'm just admitting the students who are coming late. Right. I repeat this explanation. Working principle of SCR material will be provided, but what exactly we have to explain? SCR is a 4-layered, 3-terminal, 3-junction device. When SCR is properly biased, junctions J1 and J3 are forward biased and junction J2 is reverse biased. In order to explain the above statement, Let us imagine, yes, in order to explain the above statement, let us consider the forward bias. Forward bias definition says that if the current enters the P terminal first, what is the definition of the conventional current? Conventional current always flows from positive terminal to negative terminal. If the current enters the P terminal first, then the voltage at P layer is greater than the voltage at N layer. Therefore, the junction J, yes. Anyone student confirm is my voice is audible? Any student unmute or chat in the chat you can mention. Voice వినిపిస్తుందా?
వినిపిస్తుంది సార్.
Okay, right. Thank you. Right. When SCR is properly biased, so why the junction J1 is forward biased? This is the most important point. Since junction J1 as the P terminal, the P layer is connected directly to the positive terminal. If the current enters the P layer, then the voltage at P layer is greater than the voltage at N layer. Therefore, junction J1 is forward biased. Let us explain for the J2. Why the junction J2 is reverse biased? Anyone? Because for the junction J2, we got N layer and P layer. But N layer, current is entering first the N layer after the P layer here. So current starts from the positive terminal. It has done with the J1. Now for the junction J2, current is entering the N layer. Therefore, the voltage at N layer is greater than the voltage at P layer. The junction J2 is reverse biased. Similarly, for junction J3, which layer the current is entering first, P layer or N layer? You can see on the screen, the current is entering the P layer. Therefore, the voltage at P layer is greater than the voltage at N layer. Therefore, the junction J3 is forward biased. Now, when SCR is properly biased, junction J1 and J3 are forward biased, junction J2 is reverse biased. Now, this state is called forward blocking state or off state. So, if I am using the SCR to control the speed of the motor, all the junctions should be turned on. But now the concept is what? Only junction J1 and J3 are on and junction J2 is off. So what we have to do? We have to make the junction J2 also forward biased in order to control the speed of the motor or in order to turn on the SCR. So one simple conclusion is nothing but when you apply DC voltage to an SCR, all the junctions should be turned on and all the junctions should be forward biased. Then only SCR is said to be turned on, or else SCR is completely off. So what is the problem here? So only J2 is off. We should create a new technology to turn on the J2. So let us go for the next slide. Right. So now the explanation here. So material I will provide, but I repeat the statement this one. Today's class we concentrate on SCR only. SCR is a 3-terminal, 3-junction, 4-layered device. When SCR is properly biased, the junctions J1 and J3 are forward biased and junction J2 is reverse biased. Junction J1 is forward biased since the current enters the P layer first. The voltage at P layer is greater than the voltage at N layer. Similarly, for junction J2, voltage at N layer is greater than the voltage at P layer. Therefore, the junction J2 is reverse biased. Now, when the junction J2 is reverse biased, that is our next concept which we discuss. You can see this particular slide. While explaining in examination also, you should put the simple diagrams. This is again the SCR, where now we are highlighting J1 and J3 are forward biased, okay, but J2 is reverse biased. You can see one dark line we have mentioned, even though we are giving the supply. So what is the disadvantage if J2 is reverse biased? SCR cannot be used if J2 is reverse biased. We should make the J2 also to change its state from reverse bias to forward bias. So what happens? Here is the explanation we have to give. When junction J2 is reverse biased, depletion region is created at junction J2. This depletion region contains immobile ions which will not make the movement of holes and electrons to move from one region to another region. So junction J2 is reverse bias means we should represent the reverse bias condition with simple depletion region. So now we just move to the next one. You can view this animation here clearly. Now you see the animation will start. You see we got P type and N type layer, holes and electrons. We are clubbing them, both of them. electrons and holes, they move from one region to another region. Few electrons will be depleted at the junction. These electrons will be converted into the ions, positive ions and negative ions. Once these ions are created, depletion region is formed. We are supposed to break that depletion region, then only junction J2 is forward bias. Now with the presence of this depletion region, we say that junction J2 is operating entirely under reverse bias condition. Okay. Now you can see after the statement, after creation of depletion region, if any hole is trying to move from p type to n type, it is repelled by the positive ion, positive polarity. So if junction J2 is reverse biased, the holes and electrons cannot be able to move from one region to another region. So we have to break that depletion region. So we move here. This slide is explaining only when junction J2 is reverse biased, what is the depletion region? The depletion region contains the immobile ions, positive and negative. So it happens. You can see once again, when P and N type are clubbed together, there is a movement of charge carriers. Few charge carriers convert into the ions, which are depleted across the junction, which will not make the further movement of the electrons and holes. So what we have to do? How to make the junction J2 forward biased? So forward breakover voltage. The value, practical value is 150 volts. Whatever the DC supply we are giving to the SCR. In this animation, we have shown the gate terminal is connected to the battery, but imagine we are not using the gate terminal. So I am increasing the voltage applied to the SCR from 10 volts to 150 volts. So initially, let us say we are giving 10 volts. In order to give, if I am giving the 10 volt supply, the junction J1 and J3 are forward biased, but the junction J2 is reverse biased. In order to make the junction J2 forward biased, the voltage is increased from 10 volts to 150 volts. So this particular voltage is nothing but the forward breakover voltage. What will happen if I increase the voltage from 10 volts to 150 volts? So the depletion region across the junction J2 breaks down and completely there will be the flow of the charge carriers. So the definition is the voltage at which the depletion region width decreases or eliminates is nothing but the, or the voltage at which the SCR is on is called the forward breakover voltage, another name cut-in voltage. So decreases this forward breakover voltage decreases the width of depletion region and conducts the junction J2, that is finally J1, J2 and J3 are forward bias. Now the SCR is operating under forward conducting state. So what exactly is happening when I give this voltage 10 volts? Let us say in this diagram we are giving the voltage 10 volts. With 10 volts only junction J1 and J3 are forward biased and the junction J2 is reverse biased. If the junction J2 is reverse biased, we cannot use the SCR. So what is the technique we are using? We are increasing the 10 volts to 150 volts. So if I am using 150 volts, the junction J2 is depletion region is also eliminated and all the three junctions are forward biased. Now we can use the SCR. But here there is one disadvantage. If I am using 150 volts to turn on the SCR, then nobody is going to buy the SCR in the market. We are supposed to turn on the SCR with 5 volts maximum or 5 to 10 volts. That is our challenging part. So now we introduce the terminal called the gate. So the first part of explanation is nothing but SCR operates under forward blocking state and SCR operates under forward conducting state. Forward conducting state is a state where all the three junctions are forward biased. In forward blocking state, only junction J1 and J3 are forward biased. Now let us continuation this one, the working principle. Now how we are going to turn on the SCR with the help of gate terminal. You can see the circuit here. So now we have placed the switch. When the switch is closed, the supply is given to the gate terminal. Now one more most important point we have to highlight here. Why the gate terminal is connected at P layer? Always in an SCR, gate terminal is placed at P layer close to the cathode region. Any student can give the answer why gate is placed here only. Why not it is placed at P layer close to anode or N layer close to anode? Why it is placed at P layer close to the cathode? Now I'll give the explanation. If you see initially at junction J2, now imagine that I am not using the 150 volts. I want to turn on the SCR with only 5 to 10 volts. The gate terminal is placed at P layer close to cathode region. Gate terminal is especially used to turn on the SCR with less voltage. Okay. Now what we do? you can see with the gate triggering method, only 5 volts max is required to turn on SCR. How many different types we are having? DC triggering, you can see it on the screen. DC triggering, AC triggering, pulse triggering. So generally here in the animation we are supposed to show the first DC triggering. Later on we will discuss the pulse and different types of triggering. Now let us imagine that switch is closed. I am applying the 1 volt DC supply. So when P-type, you can concentrate here on the P-type. The P-type region contains the majority charge carriers as holes. When gate terminal is excited by DC voltage, here comes the statement. I'll provide the material for this one. When the gate terminal is biased or excited with DC voltage, holes in the P region receives that DC supply as well as gains their kinetic energy. You can see gate is connected to P layer. As the holes in P layer are repelled by positive polarity, as a result, charge carriers gains kinetic energy, breaks the depletion region and passes the junction. So what's going to happen here? Initially, junction J2 is reverse biased. We are not giving the 150 volts right now. Only 10 volts we have given. Remaining junctions J1 and J3 are forward bias. But how to make this junction J2 from reverse bias to forward bias condition? So DC voltage is applied to the gate terminal. DC voltage is applied to the gate terminal, which is connected to the P layer. Holes in the P type, holes which are present in the P-type material are repelled by positive polarity, finally gains the kinetic energy, and they travel from P-type to N-type. In this way, as I increase the voltage from 1 volt, 2 volt, 3 volt to 5 volts, the width of the depletion region decreases and there will be a free movement of charge carriers from P-type to N-type and from N-type to P-type. This is what the gate triggering is all about. So in this way, we are going to turn on the SCR very early. Now you can see the last slide here, SCR characteristics. This is a symbol and simple block diagram. Now you can see, take the, okay, all the currents we'll discuss, but first concentrate on the upper left hand side, right hand side. So what is this curve? Why we are getting this particular curve? You can see here one word for VBO. VBO stands for forward breakover voltage. So first imagine that I'm not using any gate terminal and SCR is able to turn on at 150 volts. So here it will turn on. Right. In order to explain this one, let us show. Right. If we are not using the gate terminal, SCR takes certain time to turn on. What is the voltage at which SCR, all the 3 junctions are turned on? Forward breakover voltage. SCR will turn on at this value. I'm just drawing here. I hope everybody is having a look at that one. Right. Now, so after this one, let us say I'm just using the gate terminal and we are very early we are going to turn on the SCR. Gate voltage is 1 volt. So here it will turn on. So in all the textbooks, instead of drawing all the vertical lines, they have shown the explanation is if the gate voltage or gate current is 1, so here the SCR will be on. If I'm increasing the gate value, slowly the SCR goes on, turning on very early. So immediately we can turn on this particular SCR at this point. That's why the graph is explaining that here without gate terminal, here the gate terminal values with the increase of the gate values. Let's see the next one where we kept the, yes. We can have a look at this forward conducting state. First, the point here represents that we are not using any gate terminal and the voltage used to turn on the SCR is 150 volts. That's why IG current, gate current is equal to 0. So if I'm using the gate terminal, then very early with 5 volts or 10 volts, we are going to turn on the SCR at this point. Here the explanation of this particular curved line is the gate voltage is selected as 1 volt and the current is 1 ampere. So if you are increasing the gate voltage from 1 volt to 2 volts, 3 to 4, finally you will achieve the turning on the SCR at a very early state, this particular red line. So this graph is nothing but the curved graph similar to the diode. This is a forward blocking state. So in forward blocking state, junctions J1 and J3 are initially forward biased, and in order to make the junction J2 without gate terminal, we use the 150 volts concept. But in order to turn on the junction, in order to turn on the SCR very early, we can even use the gate terminal, thereby obtaining the junction J2 in a forward conducting state. So SCR contains 3 junctions, 3 terminals, and 4 layers. When all the 3 junctions are turned on, the SCR is operating under forward conducting state. So forward conducting state, this is the curve, the basic curve with the increase in the gate values. These regions will discuss what exactly the reverse, the forward blocking state is represented here. When SCR is under forward blocking state, reverse saturation current flow, that we cannot, no need to mention in this particular explanation. Only forward blocking state as well as the forward conducting state we are highlighting here. Now, next state, SCR operates under forward blocking state, forward conducting state, and reverse blocking state. The last state. So reverse blocking state, why the name has arised here? So to the entire 4 layers of SCR we have taken, if a reverse voltage, when a reverse voltage, that is when negative terminal of the battery is connected to the P layer and positive terminal is connected to the N layer of the SCR, when a reverse voltage is properly biased, or when an SCR is biased with reverse voltage, you can see on the screen, when SCR is biased with reverse voltage, that is anode connected to negative and cathode connected to the positive, the junctions J1 and J3 are reverse biased. Why? Anyone? You can see here. This is the positive terminal. Now, with this diagram, as I already mentioned, forward bias definition says that if the current enters the N-type material, then the voltage at N-type is greater than the voltage at P-type. Therefore, the SCR is off. If the current enters the P-type, then the voltage at P layer is greater than the voltage at N layer, and hence SCR is on. Now, if you see this one, the positive terminal is connected to the N layer and negative terminal is connected to the P layer. Now, when positive terminal is connected to N layer, the current starts to flow from positive terminal to negative. So now the current is entering which layer first? N layer. So when the current enters the N layer first, voltage at N layer is greater than the voltage at P layer. Therefore, the junction J3 is reverse biased. Now, similarly, let us guess the explanation for J2. Current is entering which layer now? P layer. If the current enters the P layer first, the voltage at P layer is greater than the voltage at N layer. Therefore, the junction J2 is forward biased. Now, if you see for the junction J1, now the current is flowing in this direction, opposite direction. The current is entering which layer? N layer. Therefore, if the current, since for the junction J1, current is entering the N layer first, the voltage at N layer is greater than the voltage at P layer. Therefore, the junction J1 is reverse biased. So in this way, we say that when SCR is reverse biased, the junctions J1 and J3 are reverse biased. When SCR is biased with reverse voltage, the junctions J1 and J3 are reverse biased and junction J2 is forward biased. Now, when both the junctions are reverse biased, you cannot turn on the SCR. If you are increasing, now you can see the last image here, in order to make the junctions J1 and J3 forward bias, I'll maximum this one. In order to make the junctions J1 and J3 forward bias, if reverse voltage is increased, then what's going to happen? Then temperature increases, as well as due to the increase in temperature, the reverse, there will be a breakdown region operation of the SCR. In order to make the junctions J1 and J3 forward bias, if reverse voltage is increased, then SCR operates under breakdown region. That's why there is no word called reverse conducting state. So if you are still increasing the voltage to 150 volts, you will never expect the turning on of the J1 and J3. The SCR will leads into the breakdown region. So that's why we are not having the conducting state. We are having the graph here. This particular graph explains that entire, this is nothing but the reverse breakdown region. So when SCR is operated under reverse blocking state with J1 and J3, SCR is completely off. We cannot turn on the SCR under reverse blocking state. So what are the 3 states of the SCR? Forward blocking, forward conducting, and reverse blocking state. That's what the explanation for today. Right. I'll take the screenshot of the as attendance proof here. Right. 1 second. So how many are there? 21. I'm taking the screenshot of the people who are present for the sake of the attendance. Yes, anyone, any question is there for today's class? Today we concentrate only for the working principle of SCR. Let's go back to the slide here. Right. Any question, as all you have done with the diploma also, you can put on any question. Any student, chat box, you can use the chat box to raise the question. You can see the syllabus on the screen. So only a working principle of SCR we have taken. Slowly we'll take the different topics. Okay. Next class, the target is nothing but UJT. So what exactly the application of the UJT? So SCR basics we have done. So most probably we just the entire subject will be dealing with the different converters as well as the inverters. Now, any question from any student? Anyone, any question? CR also you can ask the question. In the chat box you can put question or otherwise, right? Okay, let me end the class right now.